We talk a lot on this deep dive about the James Webb Space Telescope, the JWST, and how it's this incredible time machine. It lets us look back, 8, 10, even 13 billion years.
Right, into the very dawn of the universe.
But the thing is, sometimes when you peer that far out into the darkness, you don't just find quiet, predictable origins. Sometimes you find something that just shouldn't be possible.
You find sheer, unadulterated cosmic
Yeah,
violence.
exactly.
And that's our focus. This deep dive is all about new JWST observations that confirm two astounding facts about black holes. First, that they can get thrown out of their own galaxies at just horrifying speeds.
And second,
And second, that they might actually be older than the stars we always thought created them.
so our mission today is to really get across the almost terrifying reality of the fastest object we've ever confirmed, and then put that into context with these new findings that suggest black holes are woven into the fabric of the cosmos from the very start.
From almost the beginning. So let's start our journey. 8 billion light years away, we're looking at a galaxy that used to be part of a duo they called the Cosmic Owl.
That's a long way to go to see a disaster.
A disaster of immense proportions. What we are looking at is the first confirmed runaway supermassive black hole.
Okay, break that down. Supermassive.
This object is a cosmic behemoth. It holds 10 million times the mass of our sun. Now, try to imagine that colossal anchor, that gravitational core of a galaxy.
It's just been jettisoned.
Catapulted. And here's the truly shocking part. The reveal. It's rocketing through intergalactic space at 2.2 million miles per hour.
Wait, 2.2 million? How do you even get your head around that number?
You almost can't. Let's try it. That's 1,000 kilometers
Yeah.
every single second.
1,000 kilometers a second. That's just dizzying.
It is. To put it in terms you might recognize, that black hole is moving at 3,000 times the speed of sound here on Earth. And while, on a cosmic scale, that's only about 0.3% of the speed of light, that's not what matters. The mass is what matters.
Yeah.
10 million suns worth of gravity moving at that speed.
The kinetic energy in that single object must be unimaginable.
It really is. I mean, the forces you would need to dislodge something so massive from its home galaxy's core are enormous. This thing didn't just drift away.
Right.
It was launched catastrophically. And that incredible speed is what allowed it to completely escape the gravity of its former home.
So we have this 10 million solar mass singularity that's been violently shot out, and it's now punching its way through the universe. What does that do to the space it's moving through?
And that is where the JWST observations become so critical. They give us these crystal clear signatures of the aftermath. You see, the black hole itself is a tiny point, but its influence, its gravitational shadow, is galactic in scale. So as it barrels through the intergalactic medium, which is pretty empty but not a total vacuum, it generates this colossal shockwave in front of it. We are seeing a literal galaxy-sized bow shock.
Like a boat moving through water.
Exactly like that. But on a scale that breaks the mind. The universe is literally parting for this thing.
Wow.
The JWST's instruments confirmed it. This shockwave is pushing the gas in front of it violently sideways at hundreds of thousands of miles per hour. That measurable displacement, that sideways motion of the gas, is the smoking gun. It proves this high-velocity kick model.
So that's the destruction at the front end, the bow shock. But I read that the sources point to something even weirder happening at the back end, the trail it's leaving.
This is, for me, the strangest part of the entire discovery. Because this destructive monster, it's also a creation engine at the exact same time. As it streaks through space, it's dragging a visible structure behind it. A colossal tail stretching 200,000 light years long.
Wait a second. 200,000 light years? That's wider than our entire Milky Way galaxy.
Exactly. It's a contrail on a cosmic scale. And here is the truly unexpected part. The gas inside that tail gets severely compressed by the black hole's passage.
Okay.
And that intense compression is triggering star formation. This runaway black hole is forging new life, new stars, in what should be desolate, empty space, far from any galaxy.
So it's not just tearing things apart, it's taking the wreckage and, 3D printing stars with it as it goes.
That is a perfect way to put it. We're looking at a trail of new stars, about 100 million times the mass of the sun in total. It's a completely new mode of star formation we've never seen before. Creation literally born from hypervelocity violence.
Which brings up the obvious question. How in the universe do you generate enough energy to throw a 10 million solar mass object at 2.2 million miles an hour?
Right, the energy source has to be as immense as the object itself. And the preferred theory, the one that fits the models best, is called the merger kick.
From two galaxies colliding.
Exactly. When two galaxies collide, their central supermassive black holes eventually find each other and start to orbit in a binary system.
They spiral in toward each other.
They spiral in, and when they finally merge into one even bigger black hole, they release an unbelievable amount of energy as gravitational waves, ripples in space-time.
Right.
But that release, that blast of gravitational radiation, isn't always perfectly symmetrical. If the waves are emitted more strongly in one direction, it's like a rocket engine. It imparts a powerful directional kick to the new merged black hole.
So it uses the warping of space-time itself as a slingshot, a hyperspeed slingshot.
That's a great analogy. That kick can easily reach the 1,000 kilometers per second we see, which is more than enough to boot it right out of the galaxy.
Now, with a finding this spectacular, it's always got to be a more
Yeah,
boring
fine.
explanation proposed first, right? What was the conventional theory for this long streak?
Oh, absolutely. Before we got the high-resolution data from Webb, some scientists suggested it was just a case of perspective. They argued it wasn't a wake at all, but a bulgeless edge-on galaxy.
Just a really flat galaxy we happen to be looking at from the side.
Precisely. A very flat disk galaxy viewed perfectly sideways. And to be fair, it fits some of the data. It landed right on something called the Tully-Fisher relation, which is a key characteristic of normal stable disk galaxies.
So what was the observation that blew that theory out of the water?
It was that gas velocity I mentioned. The JWST's ability to see that the gas at the very tip of this feature is being pushed sideways at immense speed. A normal rotating galaxy just doesn't do that. That dynamic signature is irrefutable proof of a high-speed kick.
Okay, so this runaway shows us the kinetic violence of black holes in the, let's say, the more recent universe. But the JWST is also finding things that challenge our ideas about black holes at the other end of time, the very beginning.
Yes, and this is where the mystery becomes foundational. If the runaway is terrifying because of its speed, these objects are terrifying because of their age. Webb has been spotting these small, compact, very red objects. They're calling them little red dots, or LRDs.
And red in this context means very, very old.
Very old. We're talking more than 13 billion years ago. The universe was just a baby, only 600 or 700 million years old. And many of these LRDs seem to be hosting supermassive black holes. But there's one in particular, QS01, that is forcing cosmologists to just rip up the textbooks.
Rip up the textbooks. How big a shift are we talking?
QS01 appears to be this gargantuan, almost naked black hole. It's estimated at 50 million solar masses.
50 million. That's 5 times bigger than the runaway one.
5 times. And crucially, it has almost nothing around it. Just this sparse little halo of material. It's a massive object that seems to have grown impossibly big, impossibly fast, without the galaxy you'd expect to find around it.
But our Milky Way's black hole is huge. Why is this so different?
Well, our black hole is about 4 million solar masses, yes. But it's surrounded by hundreds of billions of stars. In our local universe, a central black hole is usually 1,000 times less massive than its host galaxy. Here, the black hole is huge, and the galaxy is tiny, almost non-existent.
Okay.
And the material that is there is what scientists are calling chemically pristine.
What does pristine mean here?
It means the gas is almost exclusively the raw hydrogen and helium left over from the Big Bang. There are virtually no heavy elements, no carbon, no oxygen, no iron. Those are the chemical fingerprints left behind by generations of stars living and dying.
So this black hole exists in a place that basically skipped the whole star-making part of building a galaxy.
Exactly. It implies these black holes grew into monsters before there were enough stars to build them from. It directly contradicts the standard theory that stars and galaxies form first, and then black holes collapse from them later. It's a huge piece of evidence for the theory of primordial black holes.
Stephen Hawking's theory from back in the 70s.
The very one. Hawking theorized that maybe some black holes weren't formed from dead stars at all. Instead, they were formed in the first fraction of a second after the Big Bang, when fantastically dense regions of the early universe just collapsed on themselves.
So they were stitched into the fabric of the cosmos from the very beginning.
Almost before the beginning. And realizing that these gravitational giants are both the fastest, most destructive things we see today and possibly the oldest, most foundational structures in the entire universe. It just turns our whole picture of cosmic structure on its head.
That's the powerful connection between these two JWST findings, then. We have the Runaway, showing that raw violence can actually be a way to create stars.
A whole new mode of star formation, yes.
And then at the same time, we have the little red dots, suggesting these monsters were here first. They were fundamental to the cosmos, not just a consequence of it.
It forces you to confront that black holes aren't just an endpoint for stars. They are active, fundamental architects of the universe, whether they're speeding through the night or resting at the dawn of time.
It really makes the quiet, relative peace of our own little corner of the galaxy feel incredibly fragile, where you're just infinitesimally small compared to the kinetic energy in that one single runaway black hole.
The good news, if you can call it that, is we now know what to look for. We can spot these fugitives by looking for that shockwave and that trail of stars. The search for more of them is already underway with telescopes like Roman.
The universe is just more violent, older, and stranger than we ever imagined.
And that's the essential takeaway. These massive rogue objects are out there. They're a standard part of the cosmic inventory. Which leaves you with the final provocative thought.
If we keep finding more of these high-mass, high-speed monsters, what happens when we discover that the next one is heading eventually in our direction? That's the real horror, lurking just beyond the edge of our detection.